Hot air balloons are... No, that doesn't seem right. Hot air balloons... Well, that just seems boring. Giant balloons filled with scalding hot gas forced into the sky due to the crushing weight of the Earth's atmosphere. Yeah, that's better. These contraptions of death were invented in the late 1700s, oh great, the French Revolution, and involve sitting in a small box with a fire above your head, keeping you airborne, hence my misnomer, contraption of death. Well, actually the first flight didn't have a human head, but rather a sheep, duck, and rooster. I'll never forget you, ducky! And thus Pilatre de Rosière was credited with the first hot air balloon on September 19th, 1783. With a whopping flight time of 15 minutes, this contraption could barely fly you to the local guillotine. 2 months later, on November 21st, the Montgolfier brothers, Joseph and Etienne, would conduct their first manned flight in Paris. In 1785, Jean-Pierre Blanchard and American Jean Jeffreys would cross the English Channel. Not to be outdone, Pilatre de Rosière would be killed trying to cross the English Channel, as his balloon exploded due to the use of experimental hydrogen gas. We never learn, do we? Oh, would you look at the time? It's the French Revolution. Oh, isn't that our good friend Robespierre and the Committee of Public Safety, who used hot air balloons for reconnaissance during the battles of Choleaux and Fleury? And that was it for a few decades until America decided to have a civil war. This culminated in the creation of the Balloon Corps under Thaddeus Lowe in 1861. Bet you didn't know that, A-push people. Oh yeah, and we're also back to using hydrogen balloons. World War I would spark further inventions. While traditional hydrogen balloons were used for reconnaissance and propaganda, gigantic dirigibles, were steered by propellers and could hover over land and sea, providing detailed reconnaissance and being able to drop 2 tons of explosives. Yet these balloons had a tragic flaw. They were too proud to use anything but hydrogen. Or it was the US embargo on helium or something. On May 6, 2022, the terrible A-Push and AP Euro exams occurred. Wrong year. On May 6, 1937, at 7:25 p.m., the Hindenburg burst into flames, igniting hydrogen inside its shell and bringing the mighty aircraft to its knees. Miraculously, 35 out of the crew of 97 were killed in the disaster. With the dawn of World War II, gas-filled balloons would finally meet their end. With the invention of light burners fueled with propane, Ed Yost in the late 1950s was able to carry more fuel aboard hot air balloons, allowing for longer trips. This discovery was then pushed to its limits by Richard Branson and Per Lindstrand, who were the first to cross the Atlantic and Pacific Oceans in a traditional hot air balloon in 1957 and 1991, respectively. Now that's great and all, but how do these balloons actually work? Modern Montgolfier-type air balloons are upside-down teardrop shapes, with a small basket and propane heater at the base. Still not comfortable with the idea of a flamethrower strapped beside my head, but I guess it's okay. The air inside the balloon is then heated and the balloon inflates. This goes back to Charles's law, which states that when pressure is constant, volume and temperature are directly related. This is expressed by V1 over T1 equals V2 over T2. In our case, this means that as we increase the temperature, the volume of our balloon will increase as well. Great, now that the chemistry is done, we can finally move on to the explosions. Hang on, that still doesn't explain why hot air balloons rise. For that, we need to look at the ideal gas law. This is expressed by P times V equals N times R times T. Well, we know that P is 1 atmosphere, V is proportional to T, and R is a constant, but what's really important is N, the number of moles. Sorry, moles, not moles. In our situation, the moles remain constant since they're trapped inside the balloon, but the volume increases. This means that the density of air inside the balloon is far below the density of air outside the balloon, finally giving us lift. Yes, I can see the light at the end of the tunnel. Is the chemistry finally done? So the new equation can be found right here. No! This equation explains that the lifting force is equal to the density of the cold air surrounding the balloon minus the density of the hot air balloon times the volume of the balloon and times the acceleration of gravity. It's also important to note that the lifting force needs to be divided by the force of gravity to see how much weight is actually lifted. All we need to do is do some clever algebra, Google whatever slug is, realize that density is pretty confusing, and bada bing bada boom, look at this convenient website about hot air balloons. According to the Albuquerque International Balloon Museum, I love that that exists, a cubic foot of air weighs about 28 grams and is 7 grams lighter when it's heated to 100 degrees Fahrenheit. God bless America and the imperial system. Meaning you can lift about 7 grams. Now this source doesn't mention the original temperature of the air, but clearly this official government PDF knows what it's talking about. Yep, that means I'm going back to the complex equation. Yay! After a quick Google search, I now have a certified degree in aeronautics and can finally build my own hot air balloon.